Hello everybody and welcome back to another video. In this video we're going to be talking about one-sided limits from tables. And once again, this is KhanAcademy.org, a great website. I recommend you use it for yourself. And so one-sided limit from tables. So last video we talked about one-sided limits. But this is one-sided limits from tables. Okay, so the function g is defined over the real numbers except at x equals -2. This table gives select values of g. What is a reasonable estimate for a limit of g of x as x approaches 2 from the right? It's kind of faint, but that's a plus sign. So that means from the right. And so if it's from the right, we can pretty much just ignore all this because this is obviously from the left. And what we're trying to figure out is from the right. So we see this is 2.05 is at 7.2. 2.01 getting closer to 2 is at 7.04, getting closer to 7. And 2.002 is the y value, which is getting closer to 2. The y value is 7.008, which is getting closer to 7. So by looking at this, we could assume that the limit is 7, and we check, and that's correct. Next question. Alright, the function f is defined over the real numbers. This table gives select values of f. And what is the reasonable estimate for the limit of f of x as x approaches 1? And that's faint, but it's a minus sign. So what does that mean? It means from the left. If it's from the left, we don't really care about the values from the right because we're not trying to do anything with that. And so we have the values 0.9, 0.99, and 0.999, getting closer to 1. And the y values are 2.5, 2.1, and 2.02, getting closer to 2. So what can one assume? One can assume that, well, these values are getting closer to 1, but when it hits 1, it's at 5. So we think that it's a different graph, kind of something like this. We think it looks something like that. Again, it's not accurate, but let's get the idea. And so this is getting closer to 2. So we'd say that the answer is 2, and that's correct. Alright, and for this one, the function h is defined over the real numbers except that x equals 6. This table gives select values of h. And so 5.5, 5.95, 5.9995. But we look here. What is a reasonable estimate for the limit of h of x as x approaches 6 from the left? So from the, and you might not be able to see this from the left because it has a minus sign. This is from the left. And so some people might be confused because, okay, this is up and down. I don't see left or right. And this is just another way to rewrite it. This might seem simple to some, but difficult for others. So x and h of x goes here. And so we have 5.5, 5.95, 5.995. Sorry for the bad handwriting. I'm using my mouse. And 6, which is undefined. I'll just write a UD. And then this is -5. And this is -5.99. And you get the idea, -5.999. It's this one, alright? And so people say, okay, how do you know this? It just looks like to be going up and down. How do you know it's from left to right? Well, you look, always the number line always goes from, let's say, so you had the number line 0, 1, 2, 3, 4, -1, -2, -3, -4. So it always goes from left to right, from smallest to greatest. So smallest to greatest, and we look at the table, our table here. So this is the smallest, and this is the greatest. So that means this must be going from left to right. So we look at that, and since this is approaching from the left, we don't really care about from the right, because this is approaching from the left. So that's what really matters. And so you see x is 5.5, 5.95, 5.995, and then y is -5, -5.99, -5.999. And this obviously is approaching 6. We even see it hit 6. And what is the y value approaching? Well, look, 5, 5.99, and 5.9999 looks to be approaching -6. So that would be our answer, and that's correct. For the last problem, the function h is defined over the real numbers. This table gives select values of h. What is a reasonable estimate for the limit of h of x as x approaches negative 5? From the left. Just like in the last problem, up and down, but no, from least to greatest. And so negative 5 is lower than negative 4.8. And this is from the left because there's a minus sign right there. And so since this is from the left, this part doesn't really matter because that's not what we're trying to find. And so we're looking as x approaches negative 5 from the left. So negative 5.2, negative 5.02, negative 5.002, 6.04, 6.0004, 6.000004. So that looks to be approaching 6. And we see that eventually it does hit 6. And this looks to be approaching negative 5 when it does hit negative 5. So our answer would be 6. Some people say, oh, I thought a limit it has to be like a gap space. Something like this or something like this. But no, it doesn't. It can be, let's say even you have a just simple line. And it can be any line. Just usually it's used for gaps, but it can just be a simple line. It's like here, if this was the graph, let me change colors here. If it was like that, and this is x equals 1, you could say, even though there's no gap as x approaches negative 1, from the left and from the right, let's say this is 2, and equals 2. So it can just be a normal line. So the answer for this would be 6, and that's correct. Thank you guys for watching. See you guys next time.